And now problem number 12 is a proof that is a little bit different. So again, we're given a similar looking diagram. We're given that the measure of angle ABC, which is this large outside angle, is equal to twice the measure of angle ABD. And we need to take that fact and prove that that means that BD bisects angle ABC. So let's see how that's done. Well, we start with our original statement, which is the measure of angle ABC is 2 times the measure of angle ABD, which is given. Then we formulate the second statement, that the measure of the large angle, the outside angle ABC, is equal to the sum of the measures of each of the smaller angles that make it up. The measure of angle ABD, which is this angle here, plus the measure of angle DBC, which is this angle here. That is because of the angle addition postulate. Okay, so far so good. Now, we then come to the statement that 2 times the measure of angle ABD equals the measure of angle ABD plus the measure of angle DBC. Now, I want you to take a look at these first two statements and try to decide on your own before we go any further what is the reasoning, what is the reason that justifies us saying this. Okay, now what I hope you realized is that we have two equalities here, both of which have measure of angle ABC on one side. Okay, so that means we can use transitivity, and we can say that we can therefore say that directly 2 times the measure of angle ABD equals the measure of angle ABD plus the measure of angle DBC. So we could say that this is due to transitivity. We could also use substitution. Okay, so this is very often when you can use transitivity, you can also use substitution. So we can say equally validly that because we have the measure of angle ABC on the left side of the statement, and we know that the measure of angle ABC is equal to 2 times the measure of ABD, we can simply substitute 2 times the measure of angle ABD in for the measure of angle ABC. So let's call this substitution. But you would be completely correct if you decided to call it transitivity. Either one, in this case, are fairly equivalent. Okay, so we have this statement, 2 times the measure of angle ABD is equal to the measure of angle ABD plus the measure of angle DBC. So then how do we get from the third statement to the fourth statement? Well, we are subtracting both sides by measure of angle ABD. So we basically subtract the measure of angle ABD from the left side and subtract the measure of angle ABD from the right side, giving us 1 times the measure of angle ABD on the left, and the measure of angle ABD cancels out on the right, and we have the measure of angle ABD equals the measure of angle DBC. Okay, so this is the subtraction property of equality. And finally, we conclude that BD bisects angle ABC, and the way we can conclude this is because this is the definition of bisecting. If the measure of angle ABD, which is the small angle on the left, equals the measure of angle DBC, which is the small angle on the right, then BD must be an angle bisector. So we get this answer because of the definition of angle bisector. Remember that the definitions, all definitions are biconditional statements. They go either way. So we can say that BD is an angle bisector of angle ABC if and only if angle ABD equals angle DBC. That means that we could say if BD is an angle bisector, then ABD equals DBC, or we could say it the other way around. Remember, a biconditional, the converse of a biconditional is true. So we can say that if angle ABD equals angle DBC, then BD is an angle bisector. And that's what's going on here. We're actually using the converse of the definition of an angle bisector, but that's fine because the definition is a biconditional statement.